Good day, everybody. Good afternoon, good evening, good night, good morning, wherever you are. Good timeless, you could be in space where the concept of time is a continuum or whatever the hell people say. Hi, my name is Sani Yusuf. I welcome you to Foundations of Programming, where I'm going to be sharing with you greatness about programming, just in basic in its basics or the foundations basically. And this was originally kind of recorded, but I didn't really like the quality of the other one. So now I've written the proper slides, and I'm going to be sharing these slides with you. And then let's actually move on before I start talking too much. All right. Hi. Get to know me. I am Sani Yusuf. If you don't know me, I'm the founder of Hybrid. I'm also the founder of UI School. You can check ui.school. This is a new thing we're doing with myself and my partner Nene John. I co-organize Ion UK. I'm a Nigerian and I live in England or the UK, as some of you may know. I'm an author and a trainer. I recently traveled the world, and I'm a very big fan of the Avatar movie. You can find me online at sannyyusuf.com. You can tweet me without following me. You can send me DMs and everything. You can follow me on Medium and also add me on LinkedIn. All right, without further ado, what are we going to cover today? What is this? So, again, this is Foundations of Programming. And who is this targeted to? So this is targeted to a lot of people that really just want to learn how to program or conceptually understand the basics of programming. And you don't have to be a beginner only. You can also be someone that's already programming, but you want to refresh your understanding of the basics or get deeper into the basics to really understand that conceptual or to really get that conceptual grasp of coding or programming, as people know. So what am I going to cover with you today? Well, we will be covering just a general introduction to programming, why we need programming languages, a list of some programming languages, why we are going to be primarily using JavaScript in the entire series, because this is a series, this is just the first one. There are going to be subsequent videos and slides that will be added later on, and we're mostly going to be using JavaScript. At some point, we might show examples for, from languages like Java and C# to explain some of the much more object-oriented concepts. But most of the time we're going to be using JavaScript. We're going to talk about something called primitive data types. We're going to talk about variables and also operators. Now, again, this course is going to be kind of like that, where you can just follow on. You don't necessarily need a big computer or anything. You can actually just use pen and paper and just get the conceptual understanding. It would be nice if you have a computer so that you can follow on lately, but they're going to be examples, so you don't necessarily need anything. A pen and paper and you just listening to my very gorgeous voice will be fine. Alright, let's get started. So what is programming? This is what a lot of people that want to start programming or that are even programming today, you ask them, what is actually programming? And you heard different things. It's actually not as hard or as scary as a lot of people make it seem like, or you are made to believe. Programming is like maths, right? For mathematicians, maths is just simple. But for us, a lot of other people that don't really understand maths were made to believe that it's difficult. And as well, programming and maths have a close relationship, but they're not necessarily, you don't need to know maths to know how to code. Knowing a lot of maths would help you write better logical programs. But program is more about logic and just really telling a computer what to do. So what is programming? In my definition, programming is our way of issuing instructions to a computer using a language that we understand. And this is just my definition. So it's your way of saying, hey computer, I want you to do XYZ, but you're going to tell it in a language that you understand, and the computer does it in the executes that command, because the computer does not understand you and you don't understand the computer. Computers are very smart, but they need you to tell them what to do. They're like pets. Pets are very smart, but if you tell a dog sit, it sits. If you tell it run, it runs. If you tell it catch or fetch, it fetches. If you tell it, bite, it will bite. But on its own, sometimes it needs that human help. And that's how kind of, not the greatest analogy or metaphor, but that's how programming languages are to a certain degree. When you go to a new country, like maybe let's say I'm Nigerian myself, so I speak English. But if I go to a place like Japan, I would struggle to communicate with the Japanese people because they speak Japanese and I speak English. But how cool would it be if I was able to say, "Hello, my name is Sunny," and the person that was in Japanese did not need to understand English and he just understood me, but he heard Japanese. He heard the equivalent of Japanese. That is what programming languages allow us to do. They allow us to communicate. How cool would it be if you didn't understand a language, you could just speak whatever language you understood, just like in those sci-fi movies, and the other person just understood you, but they heard the language they understand. So there was a streamlined communication. That's what programming languages allow us to do. So a lot of you are just saying, what does that even mean? And that's exactly, let me just go ahead and really explain what I mean. So your computer only understands binary. You remember how I said, like, when you go to like Japan and you speak only English and they speak only Japanese? Exactly. So binary is what your computer understands. And this is what binary looks like. It's zeros and ones. That's all binary is. Binary means by, two, just one and zeros. These are the only two values. Now, this actually is code that represents something. We don't know what it is. But if I was to tell you to read this, you'd have a hard time understanding this. Like, what the hell is this? Like writing binary, if you were to write binary to issue commands to your computer, you would spend days and weeks just to tell it, print my document for me. That means you'd spend time actually trying to tell your computer what to do. Imagine where, it's just like you're trying to speak a different language to someone and you're trying to, like, let's say, for example, let's go back to my Japanese and my English example. You've never written Japanese in your life, and then you need to tell someone in Japanese, "Hi, where can I go to eat?" Imagine you having to go to Google and looking for the Japanese keywords and writing it down and then showing the person. You'd probably die of starvation before that happens. Exactly. Now, except if you're the guys from the Matrix, where you can pretty much do everything with binary, you're probably going to struggle to use binary to issue commands to a computer. It's going to take a lot of time, right? So, for example, let's use a very quick comparison. So this particular value here, the zeros and the ones that you see, is actually the same thing as just writing programming. Like this, if you take this programming, this text here, programming, and convert it to binary, you will actually get this. Now, you can see how it's so easy to read programming. But if I told you to read this, hey, why don't you interpret this for me? You would spend ages. And you can see how much longer and how much more space it takes, which means we're not going to be efficient. If we were writing words to save our lives, I would probably survive if I was writing this in comparison to the person that was writing this. Now, imagine what much more code for more complex things would look like. Let's just go back. This is just program. Imagine if you had to write an essay. Now, if you imagine you had to write an essay in binary. Now, imagine if you had to write, shoot a movie in binary. Imagine if you had to create a game in binary. That would really, really, really suck. So what's the solution? So when computers were made, people started looking for solutions and they came up with programming languages, right? Because people did not want to write binary because binary is long, tedious, it's great, but it sucks. So what do programming languages do? This is how they work. Let's start from the bottom right-hand corner. You are the programmer. Now, programming languages are basically just languages that we've created. The same way we've created English and French to understand each other. It's a language we've created to understand, to communicate with the computer. So what we do is, it's like the programmer here writes his code in language that he understands. For example, this is a code here. And I'm not going to tell you what language it is, but if you understand English, you can just see that, socket, options, if, this, connecting, had error, handle, host, is number. Like, of course, it still looks like gibberish, right? But you can kind of read it. You can kind of like make out the words. It's English, it's words, You can kind of see options, else, so many things, return, new. You can see English words. And this is like, so the same way you would learn English or maths you learn English or French or German or Spanish or Japanese is the same way you learn a programming language. For example, English has certain words. Like, for example, I speak 4 languages, so I understand English, French, Hausa, and Arabic. there's some differences between Arabic and English. In Arabic, I write from the right to left. In English, I write from the left to right. In Arabic, you have two types of plural. So you have a word for one boy, you have another word for two boys only, and you have another word for three boys and above. But in English, you have just one type of plural: boy, boys; girl, girls. But that's so each language has rules, and that's very, very similar to programming languages. They all have their own syntax rules. How you know that when you look at it, you know this is a programming language. But they also all have similarities. They follow the very similar rules or specs, but they all have subtle differences. So let's go back to our example here. Our programmer writes this beautiful code. Now, what the programming language does, it then maps to binary for you. And some programming languages use what we call a compiler. We're not going to get into what a compiler is. That is not what we're aiming to do. We just want to get the conceptual understanding of the basics, not what a compiler does. So a programming language is just going to translate that code for you and then end up with binary, something that the computer would understand and execute. So if you said computer shut down, that's what would happen. And that's literally what programming languages do. It's like the Google Translate between you and your computer. When you use Google Translate, you prep something, it just translates it for you in the other language. That's it. Because Google Translate already has all the mappings for word, right? Now let us proceed. So why did we need programming languages in the first place? Like I said, they give us a human, readable, friendly way of communicating with our computers. If we didn't have programming languages, we had to use binary, and that wasn't really readable. You can't just look at a bunch of numbers. For example, let's just go back a couple of steps. You can't just look at this and know that, oh, this is programming. But I can just look at this word and read it once. I'm like, oh, this is programming. I can read words individually. While here, you have to go, read out all the characters to know, okay, this is programming. You'd have to read it out. And it would even be more difficult if everything was on one line, So let's just go back to where we were. And that's the one advantage of programming languages. The second advantage, it saves us a lot of time. If we were to write everything in binary, we would spend ages. But if we can just use programming languages, we can just spend little time. So programming languages are just like normal languages, for example. They have differences, just like how you have differences between English, French, Arabic, and French. Oh, actually, this is supposed to be another language. Let's just say Japanese. It's the same for programming languages. Java is different to JavaScript. JavaScript is different to Python. Python is different to C. And so many other programming languages. They're all different. They're written differently. They are expressed differently. The same way languages are expressed differently. So every time you think about different types of programming languages, just think of the different types of languages you have. Why someone that speaks English cannot understand someone that speaks French, but they might be able to get a few things, that kind of thing. It's like how maybe in English, if I say, what's it called? Like something like maybe a plate number for a car. But in French, I can say la plate, or numéro for number. Number is numéro in French, Very similar, but they're different. There's some similarities. So programming languages too can have similarities. So why should you be learning JavaScript in the first place? You must have heard of all these other languages that I've mentioned. Java, JavaScript, Python. Why would I be saying we should learn JavaScript? If you're just starting, or even if you've started programming, why should you learn JavaScript? Well, JavaScript is the most widely used language today. I don't need to have statistics to back this up, but I'm pretty sure that is very accurate. It's everywhere. It's the language of the web, and the web, is how we access the internet. It is actually very much it's relatively easier than a lot of languages. It's the same thing. For example, English is hard for some people. Like me personally, I find a language like Chinese very difficult, or Arabic. I know Arabic. So when I was learning Arabic, I struggled because I was writing from right to left. So I'll go to school and write English, and I started writing English from right to left because I was confused. It was very confusing. But some people find maybe things like English easier to learn, or I've heard people say languages like, Dutch is very easy to learn, So some languages relatively are a bit more difficult. They require more time than others. Depends on, of course, that depends on who's learning and what you already know. But JavaScript relatively is easy to learn, you know. And there are high job prospects for JavaScript. You can be a mobile developer, you can be a web developer, you can be a backend developer with Node, you can develop Internet of Things like my very great friend Yuri Sheket. Look Yuri Sheket up, he's pretty good. And JavaScript can run on any machine today. It can just run on a browser. It's running in different things now, you know, it's running in serverless today. And we're not going to get too much into that. But basically, if you want to have a future career, you want to have a job, if you learn JavaScript, you'll probably be good. That's one good thing. So let's learn some JavaScript. So we're going to start what a variable is. And this is not particular to JavaScript only. A variable is a common programming concept. All the concepts I'll cover are common programming concepts, but I'll show you how JavaScript takes its own approach to creating variables. So what is a variable? A variable is a name or a placeholder for a value. Now, what does that even mean? If you're writing maths, for example, you can say x equals 1, y equals 2. If I say x plus y, you tell me the answer is 3, since x is 1 and y is 2. If a equals, 12 and b equals 13, if I say a plus b, 12 plus 13 is 25. You understand that. But x is a placeholder and y is a placeholder, a is a placeholder and b is a placeholder. Those things are called variables. They're just there to hold a value. Now let me give you another explanation. A variable is the very variables work, especially in languages, programming languages, they're just like house numbers. If I live on street A, let's say these 3 colors represent 3 different streets, right? You can live on this street, which is this gray street or blue street and black street, or A, B, C, however you want to do, or 1, 2, 3. Each house here has a specific number. This is house number 1 on this particular street, house number 2, house number 3, right? We cannot have house number 1, house number 1, house number 1, else our mailman will be very confused. If I say, oh, I live in house number 1, then how would you know which house number 1 to go to? That's why we give them different numbers. House number 1, house number 2, and house number 3, right? Okay, now we go to the next street. We also have house number 1, house number 2, house number 3. So you see, we can't have the same house number on the same street, but I can have the same house number on a different street. So if I tell you my address, I say, I live on Blue Street, house number 1. You know that you go to Blue Street, and then you go to house number 1. And my friend can say, I live on, Gray Street, house number 1. And he can go to Gray or White Street, house number 1. And, my friend, another of my friend or my dad or my mom or my sister says, oh, I live in Black Street, house number 1. You know how to go there. So variables work like that in what we call a scoping. On the same level, when you're writing your code, you cannot have the same variable name twice. You cannot do that. But on different scopes, you can. You can name 2 different, like you can have the same variable names, but on 2 different scopes. And we're not going to get into what scopes are. But just think of this, anytime you're confused on what a variable is, it's just a placeholder. Think of the house address or house number. We give the number so that we can identify a house and we know what house we're talking about. The same way we do x equals 1. We want to give a placeholder for 1 or y equals 2, And let's move on now. Now we are going to move on to what I call the primitive data types. Now, primitive data types, what are they? They are data types that are built into a language by default. Programming languages have what we call data types. They are like building blocks. They allow you to represent things, right? For example, I can say A equals 1, but I can also say A equals Sunny. B equals Kim Kardashian. A marries B means Sunny is marrying Kim Kardashian. I can say A equals Volvo. B equals Lamborghini. I can say A equals, so I can use that variable to represent anything. But what are the built-in things I can represent? Those are called the primitive data types, right? That you can represent in language. And in JavaScript, you have what we call a number, a string, a boolean, an array, and an object. And these are not specific to JavaScript. most programming languages have, if not, I can actually say maybe all programming languages have pretty much this. All modern programming languages have these built-in data types. But some have more, some have less, and even JavaScript has one or two that we're not going to cover, like undefined and null. So let's move on. So this is how you set a number in JavaScript. You just use the keyword called let, and let is a reserved keyword. It's part of the JavaScript language. You know, you cannot name a variable let. So they're called what we call reserved keywords, right? Reserved keys hold a specific meaning, and let is what you say. Okay, whenever you say let, you say whatever is coming after is a variable name. You want to give something a value, and let is reserved, so you cannot use let apart from this case. These are the rules of JavaScript. The same way, remember I talked about how Arabic has 2 plurals and English has 1 plural. Those are the rules in Arabic. Arabic says you write from right to left, and Hebrew as well. English says no, you write from left to right. That's the rule of English. If you need to understand English, you'd have to learn to write from left to right. That's it. It's like how Greek doesn't have uppercase letters. I think so. Don't quote me on that. While English does. So you can say let's bank balance, and you can use any name and just say give it equals 1000. And this doesn't have to be bank balance. This could be, you know, just A, B, C, whatever, any text. But whatever you're doing, you make sure you just give it a number. So you can just give it a number. And then you put an end statement. And we'll talk about that a bit later. But this is how numbers they look like. You can give a number, can be just a whole number, and it can also be like what we call a float, which is a decimal number. Now let's just go for strings. Strings are like text, you know, because we want to be able to enter not just numbers when we're programming. We want to also say text. We want our code to say hello Sunny. But you need to differentiate what a text is from what a number is. And when you want to use strings, you'd have to put these quotation marks. Whatever is within any quotation mark like this is a string. And that's how you represent text. So you can say my name is Sani Yusuf. Let's country is Nigeria. So what we've done here is we've given, just if we go back to the house analogy, we've actually given this particular, like this is just like a house number. House number 1 equals Nigeria, or country number 1 equals Nigeria, something like that. And we're not going to go too deep now. Then the next is Boolean. Boolean is how we check for true, like truthiness and falseness. Truthness and falseness. So we can check if something is true. For example, if we want to know, is Usain Bolt the fastest runner? When I ask you that question, you tell me yes or no. He can be both no and yes. And sometimes when you want to represent logic, you need to be able to know something is true or false. Like, is Nigeria a great country? True. Is China the most populous nation in the world? That's true. That is a fact. You're establishing a fact. You know, is Sani the most beautiful guy in the world? Hell no. False. You know, is Sani gonna be very successful and wealthy? Hell yes. I would like that to be true. So that's how you represent. So that's what you call a Boolean. It's true or false. And we'll get into that a bit later. And then we have another one called an array. An array is basically how you represent a set of values. And it's like, for example, you want to list the days of the week. It's also, some people call it a list or a matrix for the mathematicians in the house. It's just, you can pass in, it's like a bunch of values. And then you can access those values with what we call indexes. The index is the position that the value is starting from left to right. So for example, Monday, Tuesday, Wednesday, these days of the week is now an array. If we say give me the value in position 0, because arrays, their indexes start at 0, not 1. If you say give me value in position 0, this would return Monday. If you say in position 1, Tuesday. So this is another rule of arrays. Arrays start with the index of 0. So you don't start counting from 1, you start counting from 0. So you'd say this array has 3 members, but in position 0, 1, 2, not 1, 2, 3. Very important. And then we have an object. Objects are very similar to arrays, but they're very different as well. An object is how you can have what we call a key and a value. So this is how you create an object. You use this here, and this here, these two curly braces, and whatever is inside is separated by commas. So with arrays, you use the square brackets to say what an array is, while in object you use the curly braces, and then you give a key. So this key is called name, and Sani used a favorite club. So that's how you can build like think of like a birth certificate, which is what we've done here. And when you can say birth certificate, you can say birth certificate dot name. Dot is how you use to access members of an object. And you can also do the same thing the way you do the array, but instead of passing the index here, you pass the name of the key. And this is very, very similar as well. And I know some of you are already like, oh my god, what is he saying? Sani, I don't get what you're saying. I beg you to follow on, and these things are not as scary. We're going to explain them in slides to come. So let's learn how to set variables again. So to set variables, like I said, you use the let keyword. That's what you use to set variables. You can also use other variables there are in JavaScript, like the var and the const. But we're not going to get into why we should always use the let first of all. Those are special cases. Var is very popular, but that's in the old JavaScript. What we're going to be learning here is the new JavaScript, which is ES6. Now, if you use var, that's probably still going to work, but never just use let. Always use let. So let bank balance equals 1000. And this is very readable. I'm just saying, let your name be, Sani. Let us assume. It's like speaking English, and this is the beauty of programming languages. Let salary be 1000. Let bank balance be 1000. Let my name be Sani Yusuf. Let my country be Nigeria. Let is Sani rich be false. This is a boolean. Let is Arsenal great be true. Let a variable name, and what I've done here is, as you can see, a variable name, but I've written the same thing here, but this would not give me an error. And the reason why is variable names are they are case sensitive. What do I mean by case sensitive? The reason why I write my variables like this, where after each word, the next word, we call this camel casing, I start with an uppercase, is because it's easier to read. Now compare these two. A variable name, it's much easier to read this than if I was to read this, because I would struggle. I'll be like a variable name, but here it's always good because I've camel cased it. So you can see how a variable name, it's much easier in the eye to read and everything. So that's why, and remember that they're case sensitive. Very, very important that they're case sensitive. So if you find yourself using variable names that are a bit long, camel case them after each word, and do not name your variables like this where everything is just lowercase. It's hard to read. And remember, you can use the same name twice as long as their cases are different. But you should probably stay away from doing that. So operators. What are operators? We've actually already seen one operator. One operator is the equals to operator. Is for setting something, right? We all know what equals is. I think if anyone doesn't know equals, you have to go back to basic maths. We know what equality means. It's just assigning something. If I say your Donald Trump is equals to the American president, that's what it is. So we're going to talk about the operators here: addition, subtraction, multiplication, division, and modulus. Now, the people that do not like maths, please don't run away. This has nothing to do with maths, not totally, but this is the building block of programming languages. Operators are the building. They are the forefront. Without operators, you can't write programming language. It's very difficult to write programs. Let's see how we use the addition operator. It's just you use it just like maths. You can add values together. But what type of values can you add? You can add numeric values. For example, if I say let bank balance equals to 1000 and let salary equals to 10,000, I can just say let result equals to salary plus bank balance, and this would give me 1000. So let's actually copy this code and see this running live. So what I'm going to do is I'm going to open something called JSBin, and I'm just going to Google. JSBin is like an online JavaScript sort of like workspace where you can just come here, click here, and just paste in your JavaScript code, and then you can go to the console here and you can run this JavaScript code. So what do you think this would be? So I'm saying let bank balance be 1000, let salary be 10,000, let salary be 10,000. Let me just give this some space. and I'm saying let result be salary, right? So how do we know what result is? If we want to check what result is, in JavaScript, you can actually use what we call the console. The console allows us to put things out there, and we can say console.log. It's just like a way of saying, JavaScript, tell me what this is, and what that expects us to be is another variable. We want to know what result is, right? So let's see what result is. I'm hoping that this will be 20,000. So let's run this and see. Run. And we can see here that the console has run this code. So this is how Java code runs from the top to bottom. It goes and it says, okay, what you're doing here is you're telling me that I should remember that bank balance is 10,000. And I should remember the salary is 10,000. Okay, I remember those two now. And now you're telling me I should remember something called result, but result is salary plus bank balance. So at this point, the code will say, okay, what is salary at this point? It's 10,000. What is bank balance at this point? It's 10,000. Console.log, remember, is a JavaScript feature that allows you to just show things out, and you can put in any variable there, right? You can put anything there actually, and just console.log, and it says, okay, result, and result is the addition of these two. So now let's go back to our slides. And also you can not just do only numbers, you can also do the same for what I call strings. Remember what we talked about strings, how you compare text? Exactly. So let's just go and see how they work for strings. So we're just going to give some space here, and then, so I'm already saying that this should return as Sani Yusuf Nigeria without any space, because we don't have space here. So what we're going to do here is we're going to say console.log, and we're going to say result2, and then we're going to run this. So you can see that Sani Yusuf Nigeria is what is here. And why is this here? So what this has done is it's taken Sani Yusuf Nigeria and it's just added wherever the next string is to the end. So if you had like space here and we run this now, you'd see that it will be Sani Yusuf Nigeria because we've added space to the front and everything. So strings are just like text, but they just add everything. Okay. So that's basically how addition operates. And for the primitive data types, you should only be using addition for strings and numbers. Now, some of you might be asking, what happens when we add a string and a number? Now, I would advise you to actually go ahead and Google that. What happens when you do 1000 plus, Sani Yusuf as a string? Because this is a number and this is a string. JavaScript is very funny how it handles that. And I would say, why don't you go ahead and actually check that. The next one we're going to do is the subtraction operator. This is just minus. So currently, let's go back to our JS bin and clear everything here. So if we say change this from plus and we change this to minus, let's actually run this and see. If we run this, let's actually comment this code out here. So when by commenting code, what you do is you add these two / before the anything on the first line or anything. What this tells the compiler is that do not run this line of code. So this would be skipped. This is how we can do this as well. This will be skipped. So let's run this and see. So basically what is happening here is 10,000 minus 10,000. We know that that is 0. Anything minus anything is 0. But that's what happens in result. So it takes the value here and subtracts it. So what about strings? Let's see what happens when we do it with strings and say run this code. We get an error called NaN, and what that means is not a number. It's saying you can only subtract a string from another string. Some of you might be thinking, what if we just put Yusuf here, like Yusuf, and if we're saying Sani Yusuf minus Yusuf, it should just be Sani. That's not really how it works, because strings are different from numbers. Sani Yusuf minus Yusuf can mean a lot of things. So it doesn't really apply to strings. So subtraction only applies to numbers. You must remember that. Exactly. Now the next one is multiplication, and this is not too different to what we are already used to with math. So first let's console log this out. Let's comment this bit of code out, and by adding 2 /. And let's just see times. And to show times, you use this particular, the star sign or the asterisk. And we know what 10,000 times 10,000 is, because it's going to just add all these zeros to the end of this other zero. I don't even know what number that is, but let's just do it. And we can see that now we have 1, 2, 3, 4, 5, 6, 7, 8 zeros. And I think this number is, let me see, 10,000, 100,000, 1 million, 10 million, 100 million, basically. Yes. And that's what we've got in here. And that really just what applies. And if we try to do the same thing for a string, let's see actually what happens. And when we run clear and we run this code, it shows us not a number, because we cannot multiply strings. You cannot say daddy times mommy. That doesn't really make sense. But I can say 5 times 2, and that makes sense. Okay, next, division. And we're not actually going to spend a lot of time here. Division doesn't apply to strings as well, because it doesn't make sense, of course, but it applies to numbers. So we can just comment this bit of code. We can actually just remove this bit of code here and just come here and just do this and say 10,000 divided by 10,000. And we know that will be 1. Anything divided by anything is 1. So let's clear this and run. And we see 1 here because we're console logging that, And you can do that. You can do that for any number, but you can't do that for strings. Okay. But what about the modulus operator? What is the modulus operator? Now, a lot of people that are learning how to program find the modulus operator to be a bit daunting. And it's actually pretty easy. What the modulus operator does is it gets you the remainder of a mathematical operation. If I say 5 divided by 2, I have 5 cars and I have 2 people, and I want to divide them. Now, each person of those 2 people would probably get 2 cars, but there will be 1 car left that they cannot share, except if they want to destroy the car, which doesn't make sense. So, how many cars do we have remaining after we've shared it equally? 1. That's the remainder. And that's what the modulus operator does. It does a division for you, and then it returns you the remainder. Because sometimes you want to know the remainder when you do a division operation. That's the only way you can have remainders. So for example, let's try let's go back to our JS bin and try, instead of using division, we can just say modulus, and the modulus operator is like the percent sign. It is the percent sign, so you just use the percent sign. So this, of course, it should return me 0, because 10,000 divided by 10,000 is 1. Remain the 0. There's nothing remains. If 10,000 people have 10,000 cars and they share 10,000, everybody would get 1 each, and there will be nothing left. So let's actually run this, and we see 0 is returned. So let's go back to the slides and use another example. What about if we use 10 divided by 9, for example? Now, we can just delete here and say 10 divided by 9. We know that if I have 10 cars, and I have 9 people, that each of those 9 people will get 1 car, but there'll be 1 car left. So let's do that. Let's try that. So we can actually change the name of this with I have 10 cars and I have 9 people. I'm just and I say cars divided modulus people. So I'm saying cars divided by people, but only return me the remainder, not the actual result of the division. So let's clear this and let's run this now. You see, it returns 1 because 9 people would get 1 car each, but there will be 1 left that no one would have, except if there's one person that's very stingy and I'll take everything. So this is how you use the modulus operator, and you can do you can change this to as we've seen here, we can change this to 10 and 7. Let's actually change to 7. If we have 7 people, and we have 10 cars, each of the 7 people would equally get 1 car, but there'll be 3 left, and we can't share 3 among 7 people, So let's do that. You see, it will tell us that there's 3. So the modulus operator is how you get the remainder, remember, and it's very useful. Because some people will be like, okay, why do we need to know the remainder? When you're doing a lot of things in programming, you're doing some maybe mathematical operations, you need to know the remainders. If you're calculating okay, let's say you want to know a prime number. How do you know what a prime number is? A prime number is a number that can be divided by itself and 1, right? Can only be divided by 1 and itself, So if you need to know that a prime, what's it called? what a prime number is. Like for example, 3 is a prime number. You know, what's it called? Uh, um, and that's how you. I think that's the correct definition of a prime number, if I'm not wrong. 7 is a prime number. It can only be divided by itself on 1. You can kind of use. You can create a formula, or you want to create a formula to know that, okay, if there are 2 things left when you've divided and there's 2 things left, you know what? Just give the, let's say if I have 10 cars and I have 8 people, and there's and I have X amount of people. If there are 2 cars left, give the last person the 2, or the youngest person the 2. But if there are more than 2 left, donate to charity. This is where you'd use the modulus operator. And this actually brings me to the end of this video, the end of foundations. That's all we discussed about. Let's just actually recap a little bit what we discussed about. We started by talking about numbers. Sorry, let's just go back. Let's just recap a little bit. We started first by talking about what programming is, and I told you programming is just simply a way to issue commands to a computer. You know, we talked about binary. You know, how binary is what the computer understands, but it's very difficult. As you can see, you don't know what the hell this is, except if you're the matrix. But programming languages give us a certain level of abstraction. They allow us to write something like this, and then the programming language worries about telling the computer what it is in binary. It gives us a humanly readable format. And we remember how we say programming languages are just different. They're not all the same. The same way languages, English, French, Arabic, they're all different to each other. They have separate rules and syntaxes. And then we talked about JavaScript and why you should be learning JavaScript. Very, very, very popular language and a lot of money. We talked about variables, what a variable is. It's just a placeholder. We talked about the house analogy. You know, we can have 3 different streets, but you can't have 2 house numbers on the same street, but you can have the same house number 1, house number 1, house number, but on different streets. And that's how variables work. To actually touch about that as well, it's the same way we can't come here and say let people, again, like if we're doing that, would let cars equals 10. You can see that here the compiler exactly might not necessarily complain, but what we're doing is we're overriding this particular cars now. If we say this is 2, so we have 2 cars where we're just saying, well, we're confusing ourselves. You can see how it's easy to confuse yourself when you do this. But what you'll be doing here is you just be telling this guy that, hey, override this guy. But what if you need this 10 and you need this 2? The compiler is going to be confused. It's just going to take the last guy that you initialized, and we shouldn't be doing that, remember. Primitive data types, talked about them. Numbers, first of all, we talked about strings. Remember strings in the speech quotes, and that's how you represent text. We talked about boolean for true and false, arrays for values and how they have indexes starting from 0, not 1. And we talked about objects, which are key value pairs. And then we talked about how to set variables. We talked about the operators, addition, subtraction, multiplication, and division. And then we also talked about the modulus operator. There's some other operators that are built into JavaScript, but these are the basic ones. So feel free, please, to send me next time. Actually, no, before I say that, next time we're going to go in depth into some basic syntax for JavaScript or for just programming in general. And we're going to talk about operations, simple operations that we can do. And we're also going to talk about some other basic things. You're free to tweet me, remember, at Sani Yusuf, SANIYUSUF. You can tweet me anytime for questions or what you want to learn next, or how I could improve these videos for you, how I could do better, what you want to see. And I'm going to make these slides available to you so you can actually share them and everything. And we can have like a weekly thing where anyone that's actually watched this video can come on that weekly thing and ask me questions face to face so that everyone else can learn. Thank you very much. Make sure to share this. Please give me feedback how I can improve. And thank you very, very much.